So I'm going to start now. Good afternoon. Hope you're having a good day today here in Sydney. And I'm excited to be speaking about React Server Components today. So why should you care about them? Obviously, React and JavaScript is ever relevant. And with RC, we have a completely new way to build React apps. React Server Components allow us to fade the boundary between the server and the client to create rich user interfaces with minimal client-side code while still maintaining interactivity and performance. So my goal today is to introduce, motivate, and provide resources about RC. As a non-frontend developer, you will be able to get an understanding and overview on what's happening on the front-end side of things. And as a front-end developer, you will get the tools needed to start building apps with RC and consider them for your next project. So before I start, let me introduce myself. My name is Aurora. I'm from Norway, and I work as a consultant in Oslo. I'm a full-stack dev, but I work mostly on web these days, and I'm actively building with React Server Components in my current consultancy project. I bring to you today my view as a developer joining the cutting-edge web world and how I'm learning and working with modern technology. The talking points of today will be first, rendering strategies. Then we'll get to React Server Components, what they are, how they work, and the benefits and the drawbacks. Then we'll go through the Next.js app router, then on to best practices and patterns when using RC in Next.js. And afterwards, I'm going to show you some examples of RC and a demo app that I've made. And finally, I'll give my thoughts on working with RC in a real project and the future of React Server Components. So let's begin with rendering strategies. You can't have a talk about web development without mentioning them. It's a crucial prerequisite. I won't mention every type of rendering and strategy, rendering strategy and history of the web here, but I will pick and explain some relevant topics. This stuff will probably be familiar to you guys. So static website rendering is the most basic rendering pattern where all web pages are assembled beforehand and uploaded as static files to a storage bucket. It can be built with plain HTML and CSS or combined with JavaScript. It's delivered exactly the way it's stored, meaning nothing will change unless the code is changed. And although quite simple and efficient, it doesn't handle dynamic data or interactive websites well, and is impractical to maintain. Use case could be an informational website for a business. You could say that this is the old way of making websites and is not used very much anymore. Multi-page applications, on the other hand, can handle dynamic data. In MPAs, HTML and data is merged on the server per request and sent as one package to the client. The user opens the browser and is served the merged result. And the entire page will reload per request or navigation to a new page. They can be created with, for example, the ASP.NET MVC pattern, or with PHP or Ruby on Rails. Use cases would typically be an e-commerce app. For example, Amazon is an MPA. So what are the pros of MPAs? Firstly, all the page content can be read and indexed by search engines because it is rendered HTML, allowing them to appear in search results and be optimized for it. Then, there is no restriction on the number of pages you can add. Performance is going to be the same, meaning they have unlimited scalability. And lastly, they provide more website insights. For example, Google Analytics can create reports for each page. And the cons? They have a slower overall performance because they fetch each page as a package of HTML, CSS, and JS from the server as it's being navigated to. And they can require more effort to create features. And they can be harder to maintain because each page needs to be maintained separately. Then we have the single page application, or SPA. A SPA will typically be a React app of Create React App, or Vite, or Angular, Vue.js, etc. It's been the most common way to create an application for many years. And in a SPA, the bundle.js file includes everything needed to build the app. The entire HTML is created on the client when a user opens the browser on the app's URL. And the page is blank until the JavaScript is downloaded, parsed, and executed. Then the framework, like React, will start building it inside the root div and finally load the data. And after it's loaded, only data in JSON format is needed to update the UI. The use case for an SPA could typically be any web app that needs to be highly interactive. So what are the pros of using a SPA? First, they're fast, there's no lag, they've got smooth transitions and instant information present. This is because everything is loaded initially and not requested per page as with an MPA. Secondly, they're easy to debug because everything can be logged in the browser because it's browser only, such as data, page elements, network operations. And third, since everything is downloaded initially, they can work offline and cache data and update when possible. But there are some significant cons. Most importantly, they have a slow initial load, which is increased with everything that is built on top, such as libraries. Meanwhile, the user is just looking at a blank screen and then afterwards a bunch of loading spinners. Next, search engines like Google cannot know what's on the page because the crawlers read strings like HTML. So typically a spa won't show up in Google search unless optimized in certain ways. They also need JavaScript to function, and therefore they cannot be progressively enhanced. And furthermore, they require tools existent in modern browsers and use a lot of resources. And finally, they cannot hide information from the client because data only exists there, meaning things such as API keys cannot be stored in a spa. They need a backend or a serverless function for this. So the key difference between an SPA and an MPA: in an SPA, everything loads initially and only data in JSON format is requested for making updates, whereas in an MPA, the entire page reloads per request. This brings us to SSR, which combines the advantages of an MPA and an SPA. Instead of generating the entire application on the client from the JavaScript bundle, server-side rendering means that you can pre-render the initial pages on the server and send them on demand. This lets the user go to a URL and instantly see a fully formed page with components, and they can start reading the content without waiting for React to build the page. The JavaScript required to interact with the page is then sent alongside the HTML. In relation to SSR, we also have something called static site generation, or SSG, which lets us pre-render pages in the build process of the app and upload them to a storage bucket. The result of SSG is the same as with a quick and simple static website rendering, but we can generate pages from, for example, React code. Our problem with SSG is that the build time scales linearly with the number of pages, meaning if you have a lot of pages, you could be waiting a long time to build your app. And you have to rebuild whenever the data changes. Server-side rendering is implemented in the so-called meta frameworks, which are frameworks around other frameworks, such as Remix and Next for React, SvelteKit for Svelte, and Nuxt for Vue. And these frameworks are full-stack implementations of a web app, meaning they have their own server with things happening. They support both SSR and SSG and can decide when to use what. For example, an app has a couple of pages, which one has data that is changing. So in the build process, all the static pages are rendered, and then when the user opens the app, only the page that has dynamic data will be rendered at request time. These meta frameworks also typically include things like file-based routing, APIs to handle data fetching on the server, caching capabilities, and image optimization features. Let's get back to the JavaScript that is sent along with the pre-rendered pages in SSR. We still need JavaScript to run on the client to handle interactivity. So instead of conjuring all the DOM nodes from scratch, the framework, like React, will adopt the existing HTML. This process is known as hydration. The framework will attach the event handlers and, for example, fire effects and add state, and then afterwards the page is fully interactive. However, it essentially has to rebuild the entire page and compare it with the existing one to know what to hydrate. This quote by React core team member Dan Abramov explains it well. Hydration is like watering the dry HTML with the water of interactivity and event handlers. So there you have SSR in a nutshell, done by modern frameworks like Next.js. Lets you load the initial page quickly, yet still have an interactive spa. Now this sounds great, however, SSR isn't perfect. First, after the initial fetch of the HTML, the browser will download the JS code, parse it, and execute it. So this causes the pre-rendered HTML to look fully interactive, but in fact, it doesn't contain any JavaScript yet. So the user is stuck in a place often referenced as uncanny valley, where they would click a button, but nothing happens. And the time until they can interact with the app might even be longer than what it would have been for a plain spa version of the app. So why does this happen? First, you have to fetch everything before you can load anything. All the HTML with the data fetched must be processed on the server before it can be sent to the client. Second, you have to load everything before you can hydrate anything. That's because React needs to match the tree in the server with the one in the browser to know what to hydrate. Third, you have to hydrate everything before you can interact with everything. React starts the hydration and doesn't stop until it's done. And there are many techniques being utilized in different frameworks to solve the hydration problem. Partial hydration can be used to define that only certain components need to have JS attached to them. For example, in Astro, you can define which components to load JavaScript for with client load. And we'll also see partial hydration in React Server Components later. With progressive hydration, you can lazily load components JavaScript, for example, in Astro with client visible or React suspense. Selective hydration lets you prioritize which component to make interactive first based on user interaction. This can also be done with suspense. And there are other methods being utilized as well in frameworks such as Quick, which has its own thing called resumability. Let's also mention the concept of streaming. It's a part of the Fetch API of ES6. It's available in React 18, and it's a big part of React Server Components performance. Streaming allows you to break a request down into smaller chunks and progressively send those chunks from the server to the client, and then render each chunk as it's streamed in. We can use it to send components down to the client as soon as they've been generated. So finally, with all this knowledge, we can move to React Server Components and how they solve the problems we saw earlier. What if we could decide when we needed the behavior of a SPA or an MPay or your SSR all in the same stack? I'm going to be using some simplified examples of code from my demo in this section here. So what are they? React Server Components are components that run exclusively on the server and are then streamed to the client. Server components never re-render. They run once on the server to generate the UI. And their JavaScript is never sent to the client. And when I say rendered on the server, I mean the server that is part of the full stack framework, such as Next.js, or during the build process of the app, not some .NET backend API. This is the frontend's own backend, which in many cases eliminate the need for writing a .NET API. Server components differ from server-side rendering because they are never hydrated, meaning the resulting app is partially hydrated. So hydration to non-RSC components can happen concurrently with RSC streaming in, since the compute load is shared between the client and the server. So since RSCs are exclusively run on the server, we can write database queries right inside our components. Here's an example of a simple server component called jokes list. I can query my database through an ORM like Prisma and have the data available, the component fully rendered before it's sent to the client. Server components also introduce async components, basically an async function that can asynchronously fetch data on the server without causing any issues for the client side. You can do any kind of data fetching in here, such as calling your API. So because React Server Components only render on the server, this means that a big chunk of React's API is incompatible with them. For example, we can't use state because state can change, but server components never really render. And we can't use effects because effects only run after the render on the client, but server components never make it to the client. We also can't use any browser-specific APIs because they don't exist there, such as window.location. And we can't use onClick or onChange because they require JavaScript. So server components themselves are simple, but the React Server Component world is more complex. We still want to have interactive components that include state and effects and event handlers. So because of this distinction, there are now two types of React components: server components and client components. Client components are the normal React components that you can do whatever you're used to inside. Note that they are still pre-rendered on the server during the build and then hydrated as with normal SSR. However, client components must be marked with use client. This allows us to use things like state and effects and onClick as normal. So here's an explanation from the Next.js documentation on the limitation in server and client components. If you need to fetch data, access backend resources, keep sensitive information on the server, or keep large dependencies on the server, you use a server component. And if you need to add interactivity like onClick or onChange, use state, use effects, or use browser-only APIs, use a client component. How do React server components work? What happens is that React renders server components into a special format called the RSC payload. It's a streamable format that represents the DOM, like a serialized version of a React tree. The RSC payload contains the rendered server components with holes of references to client components and the props they pass down to them. It's used both to generate the pre-rendered HTML on the server and to update the DOM on the client without a need for JavaScript. So here's what it looks like in the console. We have the initial server-side rendered HTML of the page, as well as the RSC payloads, identifiable by the _RSC name, and multiple client-side JS bundles. So all of these are used together to build the interactive page. And since this this component is defined as server only, it doesn't need to be hydrated and its JavaScript isn't shipped at all. So as with everything, it's quite complex when you start digging. We're just going to leave it at this for now. When an RSC needs to be re-rendered due to a data change, it refreshes on the server and seamlessly merges into the existing DOM without a hard refresh, updating only the parts that have changed. As a result, the client state is preserved even as parts of the view are updated from the server. And this is possible because the RSC payload only contains references to the client components and can leave them untouched. What are the benefits of using React server components? Firstly, data fetching. Data fetching can happen in components before they are sent to the client and will be faster since they can call the API or database in proximity to the resource. And inside RSCs, you have access to all your backend resources. Next, they can increase security by keeping sensitive data and logic like API keys on the server and never risk exposing them. Then caching. By rendering on the server, the result can be cached and reused on subsequent requests and across users. And bundle size. Server components allow you to keep large dependencies on the server, meaning you can exclude all the JavaScript for those components from the bundle without restricting your use of them. For example, a library like Lodash, leading to a more performant application. Server components can furthermore be streamed, meaning they can be sent in chunks and viewed as they become ready. Therefore, they integrate naturally with React 18 suspense. And finally, the developer experience. There's a lot less hassle on the client with effects and keeping data in the state. Just fetch it async off the client. RSC, however, comes with some drawbacks. Firstly, they require a framework. In practice, you will only be using them in frameworks like Next.js, which is per now the only reasonable way to use them. You become bound to the Next.js way of doing things, and it can be a lot harder to debug. Second, they create increased complexity. As a web developer, you now need to understand a lot more concepts than before when you were just making a spa with Create React App, such as what you can and can't do on the server. Next, it can be hard to onboard new developers because the learning curve is a lot steeper when aiming to write quality apps. And finally, it's still relatively new and not everything has been figured out, such as testing and compatibility with other frameworks. You risk having to refactor things or write workarounds. For example, Material UI just became compatible last July, and there have been a lot of bugs since the app router was marked as stable, but it seems to be settling down now. How can you get started with RSC? As mentioned, the most reasonable way right now is in the Next.js app router, available from version 13 and onwards. So Next.js is made by Vercel and is battle-tested and enterprise-ready. React server components are part of React 18, but developed closely with Vercel and Next.js, which is good for building apps with them because everything is optimized and working smoothly and having the entire React ecosystem follow. To make a Next.js 13 or 14 app, run this npx create command and define whether you want to use TypeScript and Tailwind and such. And then you will need the app router option set to yes to use RSC. That will generate boilerplate for you, and you can start using React server components. There's not a lot of files to confuse you. It's mostly standard stuff like package.json, tsconfig, and some Tailwind ESLint. What matters is everything inside the app directory. So in app router, you will be coding server first, meaning everything you do is a server component unless you specify otherwise, which means that the layout and the page files here are server components by default. I'm not going to spend so much time on the pages router today, but basically you don't have to use functions like get server-side props because everything is server-side by default, and you can fetch server data just by calling, for example, an API inside the component. It's a lot more straightforward. There's also a lot of changes to the file-based routing compared to the pages router, but I'm just going to explain the new app router way now. In the app router, you define routes by making folders containing a page.tsx. That makes it a valid route. Have some routes here, /jokes, /new, and then a joke ID dynamic route, meaning it's going to be parameterized. Then you can use files with reserved names such as not found and error.tsx, which are error boundaries that will render inside the layout of the route, as well as creating a suspense boundary. And all of these can be placed wherever you want to make them granularized, to the root or to the subroutes. You can also define API routes in here, like in the pages router. The route.ts file is a reserved name and will allow you to create API endpoints. Then there is support for SEO with, for example, meta tags. They can be added to any page or layout and can be generated dynamically, for example, using the route params. So with Next.js comes a lot of optimization, such as caching. All pages generated in the build can be cached on Vercel CDN if you host it there. And they will optimize your images if you use the image tag and do things like preload pages when a user hovers a link. So how do we use React Server components in Next.js the right way? What are the best practices and development patterns to get the most out of them? The best practice is going to be to move your client code to the leaves of the component tree. In this way, you ensure you do not ship any unnecessary JavaScript to the client. Then React will hydrate only these client leaves, as we know as partial hydration. You could, in theory, just put use client on your root and code however you want, but that means all your components will have their JS shipped and be hydrated, which just takes us back to normal server-side rendering. To use a client component in a server component, you can simply import it. Here, the delete functionality has been extracted to a component in the delete joke button with use client because it needs an on-click event handler. However, when going the other way around, you cannot do the same without turning the server component into a client component. Instead, you have to slot them as props, and they will fit as separate chunks into the client tree. The client component does not know what is being passed down, and this can be referred to as the donut pattern. This means that our tree can look like anything we want, and we can add client-side logic in the parent components as well. Only the green components are hydrated and contain JS here, the rest is just HTML. With this pattern, we can furthermore implement things like state management. By providing a wrapper client component with state, for example, using React context, which only works for client-side, we can use the state in the leaves without converting server components in between. For example, we can make an error message provider or a theme provider. When combined, this allows us to make apps that are extremely performant due to their large amount of static content while still being fully interactive. You could have a donut pattern, collapsible sidebar, a theme toggle provider, search, and buttons on the client side, and then the rest can be static. And you can share your state between components however you need. When building an RSC component tree, there will be some limitations between the server and the client. For example, since the client exists on the client component exists on the client, and the server component on the server, props need to be serializable. That means that we cannot pass functions through the server boundary. Instead, we must create API endpoints to communicate between them when we can't use props. Or React server actions, which will simplify the process. More on this later. How do we manage data with RSC and the app router? I already showed you that you can make database queries through an ORM like Prisma. And you can, of course, also use the fetch API. There are a bunch of parameters you can add here, such as cache duration, tags, and for validating the data, headers, and more. This is an example showing you what you could potentially do. For example, getting a cookie, making an authenticator request to an API. Getting data this way in your server components is very efficient because on the server, you have this privileged environment with everything you need accessible. If you use the same data in multiple components in a tree, you do not have to fetch it on the root and pass it down. You can fetch it in each component where it's required because it's automatically memoized. You can compare this pattern to React Query, where you will call your hooks wherever they are needed, and they will all call the same cache data. Plus, you can pass it down to the client components when you need it, for example, as the options of an autocomplete component. So what about data mutation? I mentioned that you can create API endpoints like in the Pages router, but let's skip that for now and look at something way better called server actions. They just became stable with the release of Next 14, and they are the preferred way to mutate data. They kind of complete the whole React Server Component story. So it's simple. You mark a function or a file with useServer, and Next.js will make a hidden API endpoint for you, allowing you to call it from anywhere, like from a client component, solving the problem of passing functions between the server and the client. In addition, it gives you type safety between the server and the client through RPC. Here I have a file marked with useServer, turning the function inside it into a server action. I can now call it from a client component. That's it. However, I also need to tell Next.js that I have changed something in the data inside the RSCs, and it needs to revalidate the view and fetch new data from the database. So I then call revalidate path with my relevant route. Looking at our data management graph here, the server action seamlessly takes us back from the client and to the server again. Server actions also integrate nicely with form submissions. Here I have a form and a function marked with useServer. When submitting the form, the action property, the form can, without JavaScript, call the server action and add a joke to the database. And again, I need to tell Next.js to revalidate the view. This is just some quick examples. There's so many possibilities with the server action, and it's extremely efficient to develop with. So there you have it. React Server Components in the app router allow you to do whatever you need to do, whether it's MPA functionality or interactive SPA stuff, and include SSR or SEO, or any kind of functionality you need, all in the same stack, optimized. So hopefully you remember some of these terms by now. It's a lot. React Server Components definitely bring a new mental model and architecture. We can get into a demo now of this joke cat that we've been seeing code from. It's a remake of a tutorial app from the Remix documentation, but of course very different because it uses RC and Tailwind and server actions. It's also containing very simple implementations to not clog the code with complexity. So this is an app that I've rebuilt from the Remix docs. It's using the app router and Tailwind, and it's deployed on Vercel and uses Prisma as an ORM, talking to Azure database. I might have to restart my database. It's okay. So it's pretty simple. Can you see this, by the way? Yep. There's a list of jokes here that you can view. And then you can add your own. For example, cache. Why did the developer go broke? He used up all his cache. And it's going to add it. So that's pretty much all of the main functionality here. So let's just look at the code for this. We're just going to switch to my local here. Maybe use this. Let's see. So you might recognize this from the boilerplate in the slides. There's some ESLint, prettier, Tailwind and such. And then the app router, which is the big thing here. Then there's also some components. My data access layer, which is containing server actions and the data fetching functions. And then validations for forms later, and some stuff that's not very important right now. So let's look at what's inside the app router. I have a root layout and the main page, which is this page here, which contains the next links, which are optimized. But what we want to look at is really the content here. So this is the jokes route here. And that's, since this is file-based routing, you have a jokes folder mapping to a jokes route. And in here, there's a layout with a header, footer, and the sidebar. This is actually responsive, so it's not really a sidebar right now, but hold on. You can see that it's kind of supposed to be on the side there. So the header and the footer only contains links. But in this sidebar here, we have the jokes list component, which is a server component. So in here, we can make an async function and await get jokes, which is going to make a call to Prisma and find the jokes. And then it can be sorted and mapped into links. And then there's a nav button, which is just going to take us to the create page. And a random joke button, which is just using client-side hooks to refresh the page. And then we have the new route here. So this is /jokes/new, mapping to the folder structure. And in here is the action property of the form. So this can be used to, without JavaScript, call a server action to update the database. So create joke, it's a server action with this use server here. Then there's just some validation, and finally adding a joke to the database. So what happens, we're going to create a joke here, and it's going to be added to the database and rerouted. These are new APIs for telling Next.js to get new data from your database. And then there is a dynamic joke ID route here, which is, you can see the ID in the URL. So it's going to be fetching. Actually, I'm going to, hold on. You have the route params, and then you can get the joke based on the current params. So this is not a server action, it's just getting a joke from the database, and then if it doesn't find anything, throw a not found. So I told you that you can do a lot of SEO stuff, so this generate metadata is going to be dynamically generating the title here for us with the currently selected joke. So this is server components because it's async and await. But there's also a delete joke button here, which is going to delete a joke. And this button uses client-side APIs. So here I'm using the use client directive to mark it as client-side. And then on the button click, we're going to call a server action, which is the delete joke here, which is going to delete the joke from the database, revalidate the path, and then redirect back to the jokes route. And then there's also something called use transition here, which is a new React hook, which is used to mark whatever's inside as non-blocking, meaning the user can keep interacting with other things as this is being executed. And you can also get the pending state of the function. So I'm using this here to add some visual feedback to the user that this is being deleted. Oh yeah, I forgot to mention something here. In the new form here, I'm also using a new React hook on a submit button here to give the user visual feedback. So what you can do is you can use form status to get the status of the currently submitting action inside the form here. So it's currently submitting create joke. That means we're going to get the status of this form. And if it's pending, it's going to display a pending state, right? Like that. That's pretty much it for the main functionality here, but I've added a lot of demo routes to display some RC concepts more clearly. So let's look at those as well. Let's see this. So demo. So as you can see, well, I was talking about actually that if you want to use a server component inside a client component, you have to use it as a prop. So here I'm putting a server component as a prop inside a client component. And this is going to allow it to keep being a server component while we're adding interactivity inside the client component. So I'm adding some, just using the button here. And as you can see, these are both server components, and this is a client component. And it can be more clear if we look in the console here. They're console logging something. The outer and the inner are server, and this is a client component. So as you can see, it's kind of split between the two different parts of the app here working together. Then revalidation. So I was mentioning that RCs can merge into the tree without destroying client state. So I'm going to just show you this as well. Actually, this is not so important. We just want to look at what's happening. So if I were to add some state here, this is client components, these buttons, and then we have server component stuff here. And if I add something, it's going to be merged into the tree without destroying the client state. So this is also the create joke server action here, and it's telling me to revalidate the path. That's why the data is updating, but the client state is still preserved. Global state. So I mentioned that you can create providers because you can create wrapper components with client state and then put server content inside. So we can use it, hold on, I'm going to close this again, to share state between different parts of the tree. Let's look at this as well. Yeah. So here, there's a theme context provider, which is React provider, allowing us to put server content inside here because it's a child prop, and then share the state. So I can click these buttons and use it, and then it's going to be displayed in a different component. So we have a server component, and then a component that sets the theme, this one. And then another server component and a component that uses a theme. So they can talk through these server boundary if they're constructed like this. But I actually prefer to stun for this type of global state management because you don't need to wrap this. Yeah. I have a lot of different forms here because there's a lot of different ways you can be making forms now. Just to show you that this is two different parts of the application. Let's look at this. So I have a server page here with a server form. And it's calling a server action. So this is the same as we saw earlier, calling a server action. And then it's doing some validation using Zod. So there's a Zod schema here to provide runtime validation. And it's going to say that it has to be 5 characters long on the content and 2 on the name. So what happens is if I add something here and it's not validated correctly, you're going to see that it's logged on the server. then we can also do this type of validation on the client. So here, we're going to go here. It's also using Zod to validate, but this time client side. So if we add invalid here, it has to be 5 characters, right? It's going to fail on the client side. And what you can do is you can combine this, for example, using React Hook form. So let's look at that as well. We're getting some data in a server component here. It's in the page. We can await the jokes and pass them to our client-side React Hook form. React Hook form is going to be interactive. It has to be client-side. So there's use client here, and then there's your React Hook form with the validation, same as we were looking at earlier. And then I can just show you what it looks like first. So we're going to be typing, and then there's going to be dynamic validation here, interactive, and then I'm also using a different React 18 feature here, which is called use optimistic, which is going to let us add this joke optimistically so that it pops up in the list before it's actually in the database. So let's look at that. So it's going to be there. I don't know if you saw that. It's very quick. But this time it failed because actually I have a stricter validation on the server. So if it fails, it's going to just roll back. So as you can see, you can create really interactive forms like this and just validate safely on the client and on the server, and then make it smooth and interactive and using the optimistic update. Then suspense. Suspense is actually a very important part of Next.js 14 and React Server components. Excuse me. So here I have a page, and I don't know if you saw that, but it's being loaded piece by piece. So what is happening here is the root component is 1 second delayed, and the header is 2 seconds delayed, and the jokes list here is 4 seconds delayed. So since we're working with server side here, we need to take care of components that might be slower than, well, that might be slow. They have some kind of async functionality. So for that, you need suspense. So suspense lets you mark some kind of component as non-urgent and then prioritize the content that is outside the suspense. So the suspense here is this is gonna load first, then the next part, and then finally the jokes here. When you're building with RSC, you're going to be making a lot of suspenses and building fallbacks. So the skeleton that was here is the fallback of the suspense, this one. You can also use React Query, but as you know, React Query is a client-side data fetching library, which most of the time you're not going to need when you use RSC because you can now fetch on the server. But for example, if you're going to have an authenticated route that's going to keep polling data, you would want to use this. And then what you can do is create a dehydrated state, like you're fetching data first and inserting as the initial data of the React Query data. So this is also very useful. Finally, I just wanted to show you that you can do very versatile things with server actions. So here, there's a form. We can go here. And it is, this is actually a random one. Okay. So this is going to be editable. But what happens on Blur is it's going to save through the server actions. So this is now calling on the onChange calling a server action. Sorry, on change calling set update, and then on the on blur, it's going to call a server action with a start transition, meaning we get the pending state, and then it's going to display that to the user and allow it to update. I think that's it. So I can get back to the slides now. So this is the Lighthouse score of the app. I didn't really optimize this. I just followed the RC patterns I've been mentioning. And it's small, but you get the point. So all in all, you can build very performant apps by default, and the limitations of RC will make your code better, unlike plain React, where you can do whatever you want. There's also the badge with the dynamic metadata generation here. So lastly, I have been building with RC in the real world in my current project. It's a medium scale app. So I'm just going to talk a bit about my requirements and the experience with that. It's a project set to last at least 1 year and is a rewrite of an existing MVC app with a lot of technical debt. So I've been lucky enough to be given the responsibility of picking the technology for the front end of the new solution. The app will contain interactive dashboards, complex forms, articles through a CMS, and a lot of static data, and a need for SEO. It also needs to be mobile friendly and support multiple languages and use custom authentication. Big part of the app, and something, that I made sure to proof of concept before picking Next.js and RC was the customer's design system component library. This app is a great case for RC because it can render server-side a lot of stuff, but also be very interactive where it needs to be. I'm finding it to work very well so far, but there have been some issues and learning experiences when building this functionality that is not really covered in the demo apps of Next.js. For example, I've had to create wrapper components for the customer-specific component library to be able to use them in RC and put server components inside them. I've also had to pick my internationalization library without much guidance from Next.js. It's working well, but there are certainly complexities. And finally, testing RC is not covered properly anywhere, and to test async components, there's currently a need for a workaround. But all in all, it's going well. The app is performant, fulfills the requirements, maintainable, and enforces the best practices I've been mentioning here. And the developer experience is really good. It's enjoyable. So Next.js with RCs inside it provides so many tools to let me focus on building my apps. To finish this off, what's going to be the future of RC? There's no doubt that this is the way React is going now. It's not just some hype cycle that's going to die out. It's the result of many years of work from the React team. And it's likely that other frameworks will implement their own versions of React Server Components or use them, such as Remix, who have announced that they will. There are so many solutions being proposed to improve the performance of web apps with the goal of finding the optimal balance between UX and DX. And this is React's take. Nonetheless, there's a lot of things that have yet to be figured out as server components are being battle tested. So here's the repo for the joke app. Everything is there, as well as the reference demo pages. I hope that you can be able to use it and look at the different examples when you encounter something similar. And then some more other resources that I've been using while learning this. The Vercel docs are very good. Just make sure to select the app router version. They have a lot of template apps and a full free course called Learn Next.js, which lets you build a dashboard app from scratch and then deploy it to Vercel. And for YouTube, ByteGrad does a lot of thorough RC content. And Code with Antonio does some incredible clones of apps like Twitch and Miro with full YouTube walkthroughs and GitHub and lots of stuff. He's really incredible. So I recommend this if you want to learn more. And if you have any questions about the topics that I have in my project, just reach out to me and I can send you some code or talk about it. So thanks for listening. I hope you're as excited as I am and ready to try this. My social media is here. You can contact me on Twitter, and I'm going to post my sites there. And I also have a couple of blog posts about RC. Thank you. Questions? We need a microphone, I've been told. Oh, yeah. Yes. Okay. This one.
What's been the, so you mentioned
Just hold on a minute. There you go.
all good. So you mentioned that on the current project that you're working on, you are migrating from an MVC style app to...
Yeah. Yes.
Yeah. So what's been the major challenges in moving from MVC to a more modern way of doing things?
It's not really a migration. It's just a rebuild.
Okay.
So we didn't really have to worry so much about the exact old app, except for data migration, which is not really my field. So it's new sketches in Figma, everything.
Got it.
Yeah.
Okay. All right. That makes sense.
Yeah. Yes.
How do you see the effect of this on macro front-end development?
On
Macro front-end development, like modules in different packages. Can it be combined, like a package that is developed by another team used with the same complexity of server and client side stuff?
I'm not sure about that. I don't know how many Next.js projects are like built like that, actually. Yeah, I'm not sure. Sorry. Yes.
Hi. You mentioned that the testing stuff is still catching up. I was just wondering what's the best you found so far?
The only thing that Next.js says is use end-to-end testing. So it's like, okay, that doesn't help me very much. But what I've been learning is that you can test async components with React Testing Library. You just have to either use React Canary or write like mocks when you have nested async components and such. It's a workaround, but you can test effectively still, I would say. You just have to, be aware it's going to take you a bit more effort. Yeah. Yes. There.
Can you tell me a little bit about your experience with debugging?
Debugging. Okay, so Next.js kind of hides your errors for you, consumes it in their stack. So you have to just guess a little sometimes, but it's really not that bad. It's just compared to, for example, Remix, there's more things that's been wrapped in their own error messages and such. So it's been okay, yeah, I would say. Anyone else? Okay, thank you.
I actually do have a question, sorry.
Yeah.
So I heard that Next.js is pretty hard to deploy outside of Vercel.
Oh yeah, it's a good question.
Is that true?
I'm deploying it on Azure. It's okay. You have to use a different deployment method. You have to write like a standalone version. It's just a different command. And then if you're using GitHub Actions, just link to the right places in your CI/CD there. And you don't get the built-in CDN. So I haven't set up a CDN yet. I'm going to do it at some point probably, but you have to do more manual work. But it's okay, yeah.
Thank you.